So you're doing sigma notation, huh?
Yeah, we're doing a review because we have a test tomorrow, and you can just ignore all the work I put on there. I just kind of muddled through it. Not really, so just ignore all the work I put on there.
Well, that's okay. It looks like you're correct on the first one, I think. I can't
Yeah,
quite...
the first one.
Is the first one I going from 0 to what on top?
I couldn't see, so I just implemented n because it sometimes is that, so I just did that.
Okay. So when I is 1, what is the second term going to be?
Like, what's the next I, or what's the next?
This term right here. In other words, you got the first term right. When I starts at 0, you just plug it in for 0, and you get this. But then the second term is when I is equal to 1. The thing about
yeah, that was supposed to be 3.
Right, so that's 3 over 3. And then the thing about the sigma notation is that it's discrete math. It always counts up by positive integers. You'll never see a negative number down here, and you won't see fractions either. So this term is 3 over 3. And this term would be what? You got that right?
It would be, yeah, 6 over 5.
6 over 5. So it looks like you, in general, get it, except the last term is just going to be n, 3n.
Yeah, we're supposed to do, like, one of the,
The second to last also?
Yeah, but I forgot to put the n in after.
Okay. Yeah, okay. So they want the second to last and the last term when they have you expand these like this?
Mm-hmm.
Okay. And number 2, I can't see the rest of it, but it looks like you've got the first term right, and the second term needs a square right there.
Yeah, it's got the +1 and then a square. So.
Oh, okay. I got it. Well, now hold on. You've skipped a term, if that's true. In other words, the first term is when j is equal to n, so we had n plus 1 squared. The second term is when j is equal to n plus 1.
Oh, okay.
If you stuck n plus 1 in there, then the second term should actually be n plus 2 squared quantity.
Yeah.
And the third term would be n plus 3 squared.
Mm-hmm.
And that's all you have. It is 3 terms. J goes from n, and then n plus 1, n plus 2. There's 4 terms because it's n, n plus 1, n plus 2, n plus 3. So there's going to be your fourth and final term here is going to be n plus 4 squared.
Okay.
Okay? All right, let's look at these. These are always difficult for me, too.
Yeah, just disregard my work. It doesn't make any sense.
Well, let's see if we can figure it out here, what we're looking at. Usually, I just play around with these until I get something that fits this sequence. What kind of a series is this?
It's a arithmetic.
Yeah, it is. I'm not sure that necessarily matters, but we can see that 5's being added each time.
Right.
So, what's that going to be? What can we come up with as a function where the first term would be minus 8 and every term is going to add 5. So we could have some a sub 1 plus 5n. Let me think for a moment. Yeah, that should work, right?
I don't know. Because it's giving you k on the bottom as the starting point, like k equals 1, so 1's our starting point.
Well, our starting point, okay, well, let's change that to a k then. I'm sorry, I couldn't read that. Let's make it k. And our first term is minus 8.
Okay.
Well, now hold it, I'm almost correct. In other words, that's not quite right, because notice that that is our second term.
Right.
That's our second term, and our third term is going to be correct. So if I started this at k equals 0, this would work. Correct? Now I understand that's not what they're giving you. They're giving you k has to start at 1, but this is kind of an important thing to realize. That by adjusting these numbers down here, you can actually come up with multiple answers. In other words, this sigma notation right here fits that arithmetic series perfectly. I believe when k is 0, we have minus 8. When k is 1, we have minus 3. When k is 2, we have plus 2, and so forth and so on. So, for me now, in other words, this is somewhere near correct. So now we have to figure out, well, when k is 1, how do we get a first term of minus 8? Well, how about we make this minus 13? There you go. That also produces that series.
Okay, so when k equals 2, it still works out okay?
Well, let's draw out the sequence. When k is 1, we get minus 8. When k is 2, we get minus 3. When k is 3, we get plus 2. That's that sequence.
Yeah. Okay, that makes sense. Those are just so hard to figure out. Like, there's no, like, way.
Very hard to figure out. There might be a way. Unfortunately, I was looking in my book right before I called you to see if they covered it, and my pre-calc book does not. I have another pre-calc book that might cover this stuff and come up with a better formula for coming up with these. In general, I've found them to be a lot of trial and error, just like you saw me do on this one.
Okay.
And I think that there's more than one answer. I don't think that all the answers have to be like this. I believe that that could be possibly stated a number of ways. I'm not sure.
Let me look at what the answer key says.
Okay, what answer does he give?
The answer key says that it's, oh yeah, same thing as what you put.
Or maybe 5k minus 13?
Yep, that's what it says.
Let's change it. That looks a little nicer. The thing to do on these is to play around with various combinations to see if you can duplicate the sequence. So let's take a look at number 4. See if we can figure out how to do it. There may not be a formula, to be honest with you. You know, where you can just take a sequence and plug it in, or a series rather, and plug it in. What kind of series is this?
It's multiplying by -2.
It's a geometric series.
Yeah.
Okay. Well, geometric series are actually a little easier. Because they're exponential. Let's see, J is going from, is J supposed to go from 1 to 10? Or is that little 10 supposed to be there?
That's just my work, so I don't know.
So we don't know. So let's see. Since we're doing -2, it seems like we're going to need a -2 in the parentheses. That's the common ratio. And if I have that go to the j plus 1 power, I believe that works. What's the first term?
-2. I mean, wait, 4. It says 4 right there. Sorry.
Well, by the first term, I meant figuring it out by counting up. In other words, to ensure that this is the correct thing, we need to list out the first few terms to make sure they match our series. Okay? Second term is what? J is equal to 2. So we now have -2 to the third power, which is -8. Third term, j is 3. We have -2 to the fourth power, which is +16. That's it. Find the value of the sum.
And those are the answers right there, but those are just from the answer key, so I didn't get them.
Well, we could do it the hard way, right? The hard way being what?
Doing like a full formula, but you could just add them
There's
up.
only 6 terms.
Yeah.
When you go from k, going from 4 to 9, you always have the difference plus 1. Is how many terms you have. In other words,
Right.
k goes 4, 5, 6, 7, 8, 9. That's 6 terms. So the hard way would be to list out each term and add them up. If we know that this is an arithmetic or a geometric series, then we have formulas for figuring out the sum, and we could use those. But these aren't necessarily arithmetic or geometric. Let's list out the first few terms and see whether we're looking at an arithmetic or a geometric. When k is 4, what do you got?
When k is 4, it's 5.
When k is 5, what do you have?
7.
When k is 6,
9.
what kind of series is that?
That's arithmetic, and it's +2.
Okay, so we have a formula for the sum of an arithmetic series. What is it? You remember?
No.
It's n over 2 times the first term plus the last term. Okay? In other words, it's not that hard to do this the hard way. I would only have to list the next 3 numbers and add them all up. But I don't think that's the way he wants you to do it. I think he wants you, or your teacher, he or she, wants you to figure out that this is an arithmetic series and use the formula for the sum of an arithmetic series. Because this might go k from 4 to 90. And then you need to do it the easy way, otherwise you'd be adding up numbers forever.
Right.
The easy way being to use this formula. Well, I
Right.
can tell that there are how many terms? 6. So we're looking for the sum of the first 6 terms. So n is 6. First term is clearly 5. The last term is when k is 9. That's 15. That's how we get 60. Is 5 plus 15 is 20 times 6 over 2, which is 3. That gives us 60. Okay?
Okay.
That's the way to do that one. Now, if it's not geometric or if it's not arithmetic, then it's not so easy to find the sum of some of these. You might have to list every one out. And series can be really some complex math. When you get into calculus, Calc 3 is series. This one only has 4 terms to it. So let's just list the 4 terms. By the time we figure out whether it's arithmetic, geometric, or neither, we'll have it listed. So we might as well just list it. What's the first term?
The first term is 4.
When j is 1, 1 squared is 1, so we have 3 minus 5.
So -2.
Okay. What's the second term?
Um,
And j is 2.
4 times 3 is 12. 2.
Plus 2. Remember, when you talk about series, you're always adding. In other words, I'm not creating a sequence here where I would separate them by commas. I have to separate them by either a plus sign or a minus sign. That's what this sigma means, is that you're going to add up every term you get. So what's the third term when j is 3?
27 and then minus 15, so 12.
Plus 12. And so we can already see that it's neither arithmetic nor geometric. It's not arithmetic.
Right.
There's no common difference. It's not geometric. This is -1 times that, and this is 6 times that. So it's neither. So if there were 100 terms here, there wouldn't be an easy way to do it. Fourth term is 16 times 3, which is 48, minus 20, 28. So the easiest way to add those up is that cancels with that, and you got 12 plus 28 is 40.
Okay.
Okay, now these, we can use our formulas. Now, do you have the formula sitting in front of you?
I can make that happen.
It's better if you don't.
Okay.
When you're trying to memorize something, there's a problem if you have it on a piece of paper and every time you go to use it, you look at the paper. You don't ever end up memorizing. So when you take your test, you're going to have it memorized, right?
Yeah.
So the best way to do it is to memorize it when you're practicing, when you're doing your homework. So what is the sum of an arithmetic series again?
N over 2, parenthesis, A1 plus N1.
Plus A sub n. Not N1, but A sub n. A sub n being the last term of the series. Okay?
Mm-hmm.
All right, so let's see. We know what A sub 1 is. We know what A sub n is. What we don't know is what n is.
Right.
We have to figure out what n is before we do anything else.
Right.
Well, how can we do that? In order to figure out what n is, we have to go back to the nth term definition for an arithmetic series, which is what? Let me help you with your memory. Arithmetic and geometric all start with A sub 1 in all 4 definitions. If you count this as starting, and since I can switch this, in other words, if I chose to, I could put the n over 2 on that side, same thing. So the sum starts with a sub 1 and the nth term starts with a sub 1 for both arithmetic and geometric. So if you remember that single thing, it gets you started. So you know this has to be a sub 1. What goes next? Plus sign or a multiplication sign? It's an arithmetic.
A multiplication.
No, it's arithmetic. Arithmetic means you're adding a bunch of things together. Geometric is where you're multiplying each term. So when you're memorizing the nth term for geometric series, think multiplication, but this one's got to be plus.
Okay.
What's the other thing about arithmetic sequences that's different than geometric? There's a common difference, right?
Yeah.
That's D.
Okay.
And we got to multiply that by n minus 1. Incidentally, for a geometric series, a sub n starts out a sub 1, but then we're multiplying it. There's a common ratio, and instead of multiplying the common ratio, we take it to an exponential. So if you look at the definition for the arithmetic series and the geometric series, you can kind of see a pattern that makes it easy to memorize. They both start with a sub 1. Arithmetic, you add. Geometric, you multiply. And in arithmetic, you have that common difference, only it's multiplied by n minus 1, whereas with geometric, it's a common ratio raised to the power of n minus 1. All right. Since we're dealing with an arithmetic series here, let's finish this. And this is going to allow us to solve for n. Once we solve for n, we'll have everything we need to come up with the sum. So, how do I solve for n?
If you plug it into the a sub n equation, if you plug in like the things it requires.
Huh?
So if you were to do like a sub n equals 2.5 plus that's the difference of 3, right?
It's minus 3.
Negative 3, so plus negative 3 times n minus 1. And then
It's minus 3. No, excuse me. Let me write that properly. Let's do it like this, just for clarification. Common difference is minus 3 times n.
okay.
Now, let me think about this for a second. There's another way to figure out n that's actually better. It's not this way. If we think that the first term is 2.5 and the last term is minus 75.5, how many intervals of minus 3 are there?
How many intervals?
Yeah. In other words, if I'm going to drop 3 each time, how many times is it going to take me to get to this nth term? Subtract these two numbers and you get 78. That's the distance between them. Divide 78 by 3. (26 intervals). Okay? Now, is it 26 intervals or 27 intervals?
27, I feel like.
How can we figure it out? Let's take something we can see right here. How many intervals does it take to get to minus 3.5? In other words, let's use exactly the same logic that we used, and this will tell us whether it's this number or whether it's this number plus 1 or minus 1. You see what I'm saying? Let's figure out how many intervals it takes to get from 2.5 to negative 3.5. We can see that that's n of 1, n of 2, n of 3. So that would be a sub 3 is that. Well, if we subtract those two numbers, we get 6. If we divide by 3, we get 2. So it is 26 plus 1.
Is it always going to be like that for arithmetic sequences? Like you have to add 1, or do you just have to...
I'm guessing that it's always going to be like that. I can't imagine anything would change it. So I suppose you could just memorize it, that you can take the difference between this number and this number. Actually, you should take this number minus this number, which is what we did, divide it by 3 and add 1. That'll always give you which term that is. So that is a sub 27. In other words, n is 27. Now we have everything we need to come up with the sum. We've got the first term plus the last term multiplied by 27 over 2. The first term plus the last term is minus 73. Do you have a calculator?
Yeah.
Multiply minus 73 times 27 over 2 and see if you get that minus 985.5.
Yeah, that's what I got.
Okay. Now,
can you apply the same thing to this one or not?
I'm just trying to figure that out. This is 2 times 3 times 3 times 3, so we know our common ratio is 3. And what's the formula for the sum for a geometric series?
S sub, isn't it a sub n?
Remember that all four definitions, you could say, start with a sub 1.
Okay, minus r to the n minus 1.
Times 1 minus r to the nth divided by 1 minus r.
What? Okay.
Unless I'm mistaken, that's...
No, that's true. I totally forgot about that.
But one way to remember it is, remember, all four definitions, you could start with a sub 1, even though one of them we don't define it that way. In other words, we define one of them as being this, but that technically starts with a sub 1, right?
Yeah.
So it's a way to help memorize. If you can always get a starting point, the rest of it is easier to memorize.
Okay.
Now, let's have the first term. We have the common ratio. We don't have n again. So we need to figure out n. And it looks to me like if we take this and divide by 3, no? Every term is being multiplied by 3.
We could always just plug it into the formula and do it the long way, I guess.
And the long way isn't that long here. Notice that after I get to 39, the next term is 117, I believe. Let's see, 3 times that. Yeah, 117. 3 times that is, what the heck? How did 39 ever get part of that sequence? 39 isn't in that sequence. That's a typo. Well, Jim,
Yeah. Oh wait, no. I think it's 3,900.
oh, okay.
Yeah.
Ah,
That's really
that
unclear.
is very unclear. That's a place where you should definitely not use commas.
Yeah.
Ah, okay. So how can we figure out which term that is? If we divide by 6, it almost works, doesn't it? Hold it. Our 6
Yeah.
is 2, 6, 18. The next one is 54. So if we divide that by 6, that gives us 1. If we divide this by 6, that gives us 3. Divide that by 6, that gives us 9. That doesn't work. Let's see, how could I have figured out that the 4th term was 54 multiplied by 3? So this is 3n. Sequence is, n is 2, you get 6, and n is 3. No, that's not it. I got to think about this. I know your time's up. If you want to go, that's fine. I'm going to have to think about this to figure out how to figure out which term that is.
Okay. Well, my dad actually wanted to talk to you real quick, so let me grab him. It'll be super quick.
Okay.
Hey, Dad.
Hey, Mr. Cowan, it's Michael.
Yeah, hi, Michael. How are you?
I'm good. I'm good. Hey, I know that we owe you money. Can I log into an account online and pay that way? Is there some place that shows what our outstanding balance
Do you have PayPal?
I don't.
Because
I'm not sure.
The easiest way to do it is if you have funds in your PayPal account, the easiest way is to go into my digital math tutor site and buy now. And it asks you to put in an amount, and then it'll ask you on your end only for your PayPal login information. That's by far the easiest way to pay. But if you don't have money in your PayPal account, you're welcome to send me a check if you like.
Okay. All right, I'll take a look. Erica might have a PayPal account.
And you can fund your PayPal account with a credit card, but that means you'd have to go into PayPal and deposit funds into them and then go into my site and pay with PayPal. So it might be easier to just send a check, or I don't know. It's totally up to you. I don't really care.
Okay. Do you know offhand what our outstanding balance is?
Let's see. It was $54 as of the 16th of March. Let me just look and see if she had anything after that. I don't think she did, because then there was spring break. So it's $54 going into tonight. She's going to have 3 sessions this week, which will be another 54. So by the end of this week, it should be 108.
108. Okay. Can you tell me where to send the check if we decide to mail you a check?
Sure. Let me write it on my drawing thing here, and you can just read it. Might be easier that way. It's 7320 Quarry Mountain. That's Littleton 80127.
0127. Okay.
Okay? And
Great. Yeah.
and make it
Thank you
to
very
me,
much.
not my business name.
Make it out to you. Okay. All right. Fantastic. Thanks, David. I appreciate
All
it.
right, Michael.
Have a good night.
Okay. Tell Aspen I'll talk to her on Wednesday.
Okay. Yep. I'll do that.
Bye-bye.